then allowing efficient management of a personal resources and communities and mission while ensuring the operational effectiveness and performing tracking and priority-based decision making.
So we begin our simulation in the main method, where we first initialize the disaster response system, which act as our central database for all operations. In test case 1, we started by defining foundation of any relate effort, which is the target and the team. We instantiate a community object for zone A and responder object for 1, then immediately call the register method in our system to system in our system class to ensure these entities are tracked in our global list. Once we have a people and location set up, move up naturally into case 2, where we prepare our resources. Here we create supply items for food and water. Then wrap them into supply batch object by calling the add item method. We are using aggregation to build a manifest of supplies that has its own weight and value. So here in the batch, and then it displays. With the team and the supply ready, task case 3 is where the action starts. We initialize a mission object. At this stage, the mission is just a shell, so we use assignment methods to link the responders from the case 1 and the supply batch from the case 2 to this specific mission ID. This leads to test case 4, where we evaluate the financial impact of these choices. We call the compute operational cost method, which reach into the assigned batch to pull the weights and values, then applies our distance and difficulty multipliers to give us real-time budget estimate. In the test case 5, we look at the performance side of the mission. We simulate the completion of the task by setting the execution time and success rating, which allows us to call the compute efficiency rating method. This is a crucial step because it tells us if the supplies sent were actually enough for the population zone A. Transitioning back to our personal test case 8, we take the we take that efficiency data we calculate in test case 5 and feed it back in one profile using the update responder performance method. This ensures that our responders' careers record is always a reflection of their actual mission success. In test case 9, we realize that the mission needs more support, so we register a new medicine item and call the add item to batch method. This is a great demonstration of our system flexibility as it allows us to modify existing batches mid-operation. Medicine, because we added the medicine test case 10 requires us to call the recompute mission cost method, showing how the addition of high value items instantly changes the mission's financial profile. As our operation expands, test case 11 shows us scaling this system by adding a second responder named Pedro. Finally, we arrive to test case 12, which is culmination of the uh, entire program. We call the display all object method, which is provide a comprehensive top-down view of every community responders and mission we manage today, providing that system is successfully maintaining data integrity across all classes.